We're going to graph three examples, and I'm hoping that you're starting to get a flavor for graphing rational functions after these three examples. The first thing that I probably should do is I should factor. Now, obviously, in this example, 12 is not really factorable in a polynomial sense. So allow me to look at the denominator. Is x squared plus 2 factorable? No. So I'm going to take a look at perhaps um, what is my horizontal asymptote? Well, my horizontal asymptote, I have to look towards the degrees. The degree of the numerator is 0. The degree of the denominator is 2. So this is case 1. So since the degree of the numerator is less, we have a horizontal asymptote of 0. Y is equal to 0. Now, my vertical asymptote, here, there will not be any. Now, normally we look for our non-permissible values. So here, I am going to go over the more formal definition. I know that I have a vertical asymptote whenever my denominator is equal to 0. So when is x squared plus 2 is equal to 0? Well, it's never equal to 0. Because when you square a number, it's always positive, plus a positive is never going to be equal to 0. But if you decide to carry it a step further, perhaps you're like, when is x squared equal to negative 2? Never. A square cannot be a negative. So really, all I have is a horizontal asymptote as y is equal to 0. I think now what I'm going to elect to do, this is my only guiding line. And remember, this is as x gets infinitely large, either positive infinity or negative infinity, my y value will approach 0. So this is the thought that's going to drive the left-hand and right-hand side behavior. But really, what I'm going to do is I'm just going to shoot bullets at this. I mean, I'm just going to pick random x values. So I'm going to pick negative 6, y negative 6, seemed fun. Perhaps negative 1, y negative 1. Well, I have a feeling that it's going to be symmetric. I'm just going to try these 5 values. And the reason why these 5 values is because x is equal to these. Why not? Anyways, for x is equal to negative 6, my y value is 12 over 38. So let me put that y value, negative 6, oh my god, like 12 divided by 38 is like 1/3, which is much less than 1. And that's sort of, that is going here. As x gets infinitely large negative, we will have a very small y value, or a y value that's very close to 0. Hey, I got 1 point. Now, if I put in x is equal to 1, I believe I have 12 in the top, negative 1 squared is 1. Oh, so basically this will simplify. My output would be 12 over 3, which is 4. So when x is negative 1, my y value is 4. When x is 0, my y value is, plugging in 0 there, my y value is 6. When I plug in 1 into here, I'm sorry, I should write that 0, 6. There we have it. So I have 3 dots. I'm going to connect them in the most rational way possible. No pun intended. Anyways, you could easily plug in these x values and get these y values. So I'm just going to plug in points. Now, it's almost like a shotgun approach to graphing, isn't it? It's just taking random x points and graphing it. And in fact, yeah, that's what I'm doing. So I have my function, it looks like it hits the highest here. So I'm going to start to highest, and then as x goes towards negative infinity, it's going to flatten out. So that's what it looks on the left-hand side. On the right-hand side, it looks like it starts at the highest and then flattens out as x gets large. So there we have it. Now, just a comment on my asymptotes. My asymptotes always have to be drawn with a dotted line. They must always have arrows. So there's the first example. I hope it wasn't too bad. So maybe let's go on to the next example. Oh, hopefully this won't kill me here. So my next example is we're going to graph y is equal to x minus 3 divided by x squared minus 9. I'm hoping the first thing that you do is factor. Now at any moment you want to try to tackle this on yourself, you can hit the pause button. So anyways, I factor this, and sorry for the penmanship, I should have listened to my grade 2 teacher. I factor this and I get y is equal to x minus 3 divided by x minus 3 times x plus 3. And likely what jumps out at you is that we can cancel a factor of x minus 3 from both numerator and the denominator. But our non-permissible values always have to stick with us. So this simplifies. We can cross out a common factor. And if we do that, all that remains in the numerator is just a 1. So this simplifies into 1 over x plus 3, where x cannot be equal to negative 3 or 3. So if we take a look at this function now, what we are able to see is that I have a vertical asymptote at x is equal to negative 3. In other words, where my denominator is equal to 0, and that's at x is equal to negative 3. So I'm quickly going to graph that. And now comparing the degree of the numerator and the denominator, what I get is that the degree of the numerator is less than the degree of the denominator. Therefore, I know that I have a y asymptote, or an asymptote at y is equal to 0. So I'm just going to quickly sketch those. Quick. It's like watching paint dry, I bet for you. So, and here I know that I have a vertical asymptote at x is equal to negative 3. So again, we're going to use a little bit of a different strategy here. I'm just going to say that I basically have two domains of a function. I'm curious, this is one domain over on this side of my vertical asymptote. And my vertical asymptote is sort of like a force field. This is another domain of my rational function. So there's really almost two different domains, two different functions. But I know how asymptotes behave. So over here, I'm simply going to make a table of values for both sides. And I am going to use, I'm out of room here, my deepest apologies. So this is my first domain, and I'm going to choose probably, I don't know, negative 8. Why negative 8? I don't know. I want to see what's going on over here. I'm going to choose negative 4. Why negative 4? I want to get a point somewhat close to my asymptote. And now I'm going to pick a point, negative 4.01. Now this is a symbolic point, as we see. Let us just do this. I'm going to plug in negative 8 into here. So what I get is my y value is negative 1/5. If I plug in negative 4 into this, I get a y value of negative 1. So allow me to draw those 2 points for you here. Maybe I'll switch it up and write green. So at negative 8, my y value here, and nobody's gonna say, oh, like that y value looks like negative 0.3 rather than negative 0.2, right? Negative 1/5 is fairly close to 0. So negative 4 has a y value of negative 1, so there it is. And now this is called a sign test. You know that as by the definition of a vertical asymptote, my y value gets very, very large. You can verify this with your calculator if you want. So here, what I'm going to do is I'm just going to take a look at this. If I plug in my x value of negative 4.1, will this outcome be positive or negative? Because if it's positive, it's going to go straight up. But if it's negative, it's going to go way down. Now I'm thinking that it'd probably go down as we approach the vertical asymptote. Anyways, if I plug in negative 4.01, I'm going to approach it from this side. Pardon me, I made a very significant mistake here. This should be negative 3.01. Very close to the asymptote, but just on the negative side of it. What I notice is that if I plug in that x value into here, my numerator still stays at positive 1. But my denominator is going to be negative. Negative 3.01 plus 3 is going to be negative. And for those of you at home who love to score keep, the true y value is negative 100. But I'm just going to put a point right there as a symbolic point, and to notice that this graph goes down. Similarly, I'm going to have the same argument for this domain now, because it's separated by my vertical asymptotes. I am interested, you can probably tell the graph won't be over here, so I'm interested, what happens when x is equal to negative 2? What happens, right, negative 2 would give me what's going on over here. What's going to happen at negative 2.99? That is approaching negative 3, but from the positive side. Negative 2, and let's say 0. So when x is equal to 0, my y value is positive 1/3. When x is equal to negative 2, 1 divided by negative 2 plus 3, my y value is 1. When x is equal to negative 2.99, now what we see is that my numerator is 1, so it's going to be positive, and my denominator, negative 2.99 plus 3, is also going to be positive. So the outcome of this is going to be positive. So I'm just going to graph those points. 0, 1/3, negative 2, 1, and negative 2.99, positive really high. And there it is. And by the way, there are tons of rules about asymptotes. And you'll get it a lot more in grade 12. But you can never curl away from an asymptote. I'm just going to maybe extend this a little bit longer, and I'll show you why in a bit. So I'm going to just try to extend this as long as I can, because I need to make sure that I have a point. Allow me to make sure that my function does not equal to negative 3. That is true. We have an asymptote, so our function can't be equal to that. But our function can also not equal to 3. So what I must do now is I must erase that and make a point of discontinuity at that point. So there's my function. It's not showing up very well here. I noticed in my recording, so that my function exists all the way over here. And still not showing up very well. There. Hopefully it's better. There. Hopefully this is making sense. We're going to tackle one more example.